All right, let's get right into it. For years, the only story you heard was move to the public cloud, move to the public cloud. But something really interesting is starting to happen, a big shift. Today, we're going to break down how you can actually build your own private cloud, and we'll walk through the three main ways people are doing it today.
But hold on a second. Why are we even talking about this? Doesn't it feel like swimming upstream? I mean, everyone's supposed to be going to the cloud, right? Well, it turns out a whole lot of companies are actually pulling their stuff back, and there are some really good reasons why. In fact, this whole movement has a name.
Yeah, it's called cloud repatriation. And look, this is not about going back to the stone age of IT. Not at all. It's actually a super smart move to get the best of both worlds. You get the raw power and control of having your own gear, but you combine it with that flexible, agile way of thinking that the cloud taught us. This is the big why. It's a fundamental shift in how people are thinking about their infrastructure.
So here's our game plan. First, we've got to talk about the physical foundation. The stuff you can actually touch. It's the bedrock. Then we'll explore the three main roads you can go down. Path A, the all-in-one. Path B, the true cloud. And Path C, the Kubernetes way. And by the end, we'll tie it all together so you can figure out which strategy makes the most sense for you. Okay, let's start at the beginning, laying that foundation. Because before you can even dream about all the cool software, you've got to get the hardware right. We're talking about the absolute non-negotiables: compute, storage, and networking. Get this wrong, and your cloud is doomed before it even starts. Seriously. For the longest time, the storage world was basically split in two. On one side, you had your SANs. Super fast, but wow, were they complicated and pricey. On the other side, you had NAS. Way simpler, way cheaper, but often just too slow for the really important stuff. But here's the real kicker. Both of them had the same fundamental problem. They were scale up. That means when you needed more space, you had to buy a bigger, beefier, more expensive box. And eventually, you just hit a hard limit, a brick wall. For a modern cloud that needs to be flexible, that's just a total dead end. And that's why the game completely changed. The old way of doing things, it's over. Today, the standard, the modern way to build a private cloud, is something called hyperconverged.
So what the heck is hyperconverged, or HCI? Well, think about it like this. Instead of having one giant, super expensive storage box that's a single point of failure, HCI is smarter. It takes all the hard drives that are already inside each of your servers and uses software to glue them all together into one massive distributed pool of storage. Your data gets copied across multiple servers automatically. So if a server dies, who cares? Your data is still safe and online. This is the scale-out approach that really makes the modern private cloud tick. Now, all that data getting copied around puts a ton of stress on your network. And this right here, this chart tells the whole story. Just look at this. On an old 1 gigabit network, moving a single VM takes 8.5 minutes. That's an eternity. But jump to a 10 gigabit network, 51 seconds. We're not talking about a small improvement here. This is the difference between a cloud that actually works and one that feels like it's stuck in mud. It's a non-starter.
All right, so we've got our foundation, a hyperconverged design and a speedy 10 gig network. Now we can talk about Path A, the all-in-one. And the poster child for this approach is definitely Proxmox VE. Just think of this as the fast track, the most straightforward way to get a really powerful enterprise-class private cloud up and running. What's so cool about Proxmox is its architecture. It's what's called a multi-master cluster. That's just a fancy way of saying that every server in the group is a boss. There's no single brain that can die and take the whole thing down with it. They all talk to each other to stay in sync over that fast network we just established. And the absolute best part? It has that hyperconverged storage built right in. You can manage the whole shebang from one simple web page. So how do you get it running? It's basically a three-step dance. First, you install it on the bare metal server. And here's a pro tip. Get your hostname and IP address locked in perfectly from the get-go. Trust me, you do not want to change those later. Step 2, you create the cluster on your first machine, then you just join the other servers to it. Easy enough. And finally, Step 3, you flip the switch on the HCI storage by setting up that dedicated 10 gig network for storage traffic and lighting up the Ceph services. Okay, pay attention because this is super important. For a cluster to stay online when a server dies, the remaining ones need to vote to decide who's in charge. And just like in politics, you need an odd number of votes to avoid a tie. So what happens if you only have 2 servers and one fails? You get a tie. The whole cluster becomes read-only. Basically, it's useless. The fix is a tiny little thing called a queue device. It just sits there and acts as a third vote, a tiebreaker. If you're building a 2-node cluster, this is not optional. You absolutely have to do this.
Okay, let's completely change gears now. We're moving from the straightforward to the beast. Path B is what I call the true cloud. This is when you're not just building a server cluster, you're building your own Amazon Web Services. We're talking massive scale, the ability to carve it up for different departments, or even sell it to customers. And in this arena, the undisputed heavyweight champion of the world is OpenStack.
See, OpenStack isn't just one program you install. It's more like a small city of different services that are all constantly chattering with each other. You've got Nova for compute, Neutron for networking, Cinder for storage, Keystone for security, and on and on. This is what lets it scale to insane levels, but it's also where its legendary complexity comes from. Everything relies on a central message bus and a database. If either of those has a bad day, your entire cloud just stops. Now, the good news is you don't have to build that city brick by brick anymore. The modern way, using Kala Ansible, automates the deployment with containers. But here's the catch, and it's a big one. You basically have to write the entire blueprint for your cloud in one massive configuration file. And I mean everything. One misplaced comma, one little typo, and the whole deployment can go up in flames. And just to give you a taste of what that's like, that final deployment step can take a solid 30 to 60 minutes. And when it fails, and believe me, it will fail, often the only solution is to run the destroy command, wipe everything, find your typo, and try again. It's a painful, time-consuming loop. Look, it's an unbelievably powerful platform, but you need some serious engineering chops and a whole lot of patience to tame it. And that brings us to our third and final path. And this one feels like the future. We're talking about the Kubernetes way. The big player here is a project called Harvester, and its mission is simple but revolutionary, to finally bring the old world of VMs and the new world of containers together under one roof. This is a total mind bender, so let it sink in. In this world, Kubernetes manages everything. It's not just for containers anymore. It becomes the operating system for your entire data center. And yes, that even includes your old-school virtual machines. So how on earth does that work? Well, Harvester cleverly uses a tool called KubeVirt, which basically tricks Kubernetes into running a VM inside one of its normal pods. Pretty cool, right? Then for storage, it uses another awesome cloud-native project called Longhorn to handle all the distributed storage needs. And you manage all of this through Rancher, which gives you this beautiful single pane of glass to see your VMs sitting right next to your container clusters. But what's really wild is how you set it all up. Everything, and I mean everything, is done the Kubernetes way. You're not editing complicated network config files on the command line. Nope. You define your VM networks using the same simple YAML files you'd use for anything else in Kubernetes. Same for storage. You want 3 copies of your data for safety? You just define it in a Kubernetes storage class. It's all managed through the same unified system. Whew! Okay, we've gone on quite a journey. We've seen Path A, the all-in-one with Proxmox, Path B, the massive true cloud with OpenStack, and Path C, the futuristic Kubernetes way with Harvester. So now for the big question. How do you choose? Let's break it down. This table really tells the whole story. On one side, you have Proxmox. The headline here is low complexity, low cost, perfect for small to medium businesses. Then way over on the other extreme, you have OpenStack. Its complexity is through the roof, but it's built for hyperscale. And let's be honest, the biggest cost there isn't the software. It's the salaries of the giant engineering team you'll need to run it. Harvester fits neatly in the middle. Its complexity is moderate, but there's a huge asterisk. That's if you're already living and breathing Kubernetes. That makes it a perfect fit for modern DevOps teams.
So let's boil this down to some simple recommendations. If you're a small to medium business or you're building something for the edge, honestly, just go with Proxmox. It gives you 90% of what you need with like 10% of the headache. It just works. Now, if you're a huge company or a service provider who needs to build different departments and keep them totally separate, you have to bite the bullet and go with OpenStack. You need that power. And finally, if your team's mantra is Kubernetes, 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 then Harvester is your strategic move. It's how you unify your entire world under one skill set.
So, we'll leave you with this final thought. Picking your path isn't just a tech decision for today. It's really a bet on what kind of company you want to be tomorrow. So the question you need to ask yourself is, which one of these cloud architectures actually matches your organization's future?